Would you believe it if I told you planting a garden helped a couple save their dog? Or that it also helped them save the wife from cancer? It seems crazy, and I wouldn't blame you if you didn't believe me. And yet, if you look at it a certain way, that's what happened. David R. Montgomery and his wife Ann Bickley lived in Seattle, Washington. Ann is a biologist and environmental planner, while David is professor of geomorphology at the University of Washington. They had written this book after their interest in microbial life was piqued by how they were able to grow a thriving garden in barren soil. And so they wrote the book, The Hidden Half of Nature, which talks about the history of microbiology and their experiences. The book starts by explaining their story of trying to plant a garden. When first moving into their house, the soil in their yard was dead and barren, and so Ann came up with a plan. Fertilizer was expensive, so she would create her own. She used waste organic material and continued to add it to her soil. This material was simple things, from fallen leaves to leftover coffee grinds. As this continued over a long period of time, she was surprised to find that her soil was becoming nutrient-rich and very hospitable place for plant growth. As her and her husband studied, they found that the waste that they had been applying to the soil was actually being used by an entire microbial world to help their soil. As that world grew, so did their garden. This interest in microbes led to their studying and then writing of their book, The Hidden Half of Nature. Now, to the part I'm sure you all care about. Saving the dog. Loki was Ann and David's lab. He had been lethargic for a few days and had had trouble breathing. One day, during a walk, he began to throw up, and his breathing got worse. Ann and David quickly took him to the vet, where he was diagnosed with pythorax caused by a bacterial infection. Pythorax is pus in the plural space. The real threat, however, was an overactive immune response. His body was beginning to attack itself. He was given antibiotics, and then the veterinary staff continued to suck pus out of his chest for the next 36 hours. After a long and stress-filled time, finally the antibiotics began to work and Loki was able to start recovering. Pythorax is an autoimmune disease. An autoimmune disease happens when the body recognizes its own tissue as foreign. It then causes an immune response which leads to inflammation. Inflammation is a key aspect to the immune system as it allows immune cells who kill invaders and repair tissue to start the healing process. However, this is a general process and is not tailored to each specific situation. The problem is, immune cells will keep a cycle of promoting cytokines to keep the response up, which keeps the inflammation around because the body is detecting its own tissue as foreign. This is what happened to Loki. His body was causing chronic inflammation which was threatening his life. Luckily, the antibiotics were able to take effect and stop the immune response, which saved Loki's life. Our immune systems are complex. This can be helpful, but as was seen in Loki's case, when something goes wrong, it can be life-threatening. However, not all organisms have such complex immune systems. So why is it that our immune systems are so complex? There are a couple theories why our immune systems are this way. Ann and David mentioned two of them. One that has been disproved is that because humans have been around for such a long time, they need a much more sophisticated immune system to stay alive. The problem with that is that there are animals that exist that have a less sophisticated immune system that have also been around for a very long time. Another more likely theory is that there is a complex dance between microbes that call us home and our immune system that must be played to avoid wiping out friendly species, but also regulating these microbes and pathogens. David suggests that the immune system works hand in hand with commensal bacteria to walk the line of promoting healthy microbes and ridding the body of the negative ones. The commensal bacteria will trigger a response in the immune system to prime it to fight pathogens and also reduce inflammation, which the mechanism of is not yet fully understood. Another way the commensal bacteria benefit us is they compete with pathogens for resources and space, making it more difficult for them to establish. This is an example of mutualism. Our body provides a home and food for commensal bacteria, and in return, they help defend our body from pathogens. As can be seen, microbes affect our lives in many diverse ways. This became even more apparent to David and Ann when Ann was diagnosed with cancer. In response to this diagnosis, she began to focus on her overall health. Part of this focus included focusing on her diet. As she focused on what she ate, she began to notice a general improvement in her overall health. This led to a curiosity regarding the digestive system. So David and Anne took a part of their book to write about this. As it turns out, microbes and bacteria play a vital role in the digestive system. They have many roles, including helping break down complex foods, like fiber, into smaller molecules to be absorbed into the body, extracting and absorbing nutrients from food, and maintaining overall gut health. What David and Anne found is that we can both help and hurt the microbes in our digestive system. One such way is, you guessed it, our diet. Foods ingested heavily influence the microbes in our gut. The more rich in fiber the food that we eat is, the more beneficial it is for the bacteria living inside of our digestive system. Processed foods are not nearly as helpful to our bacteria though. Antibiotics can be helpful, however, they do tend to kill both bad and good bacteria, especially broad-spectrum antibiotics. The immune system is heavily tied to the digestive system. The digestive system interacts with immune cells that are found within the lining of the gut. This helps the body distinguish between harmful and good substances that enter the body. When the digestive system is healthy, digestion also becomes more efficient and offers a variety of health benefits. This was the case for Anne. She found the healthier that she kept her digestive system, the better it was for her. She was able to eventually overcome her cancer. And as was said earlier, she focused a lot on her diet, and what she found regarding the foods that she ate deserves a second look at, as the findings were quite interesting. During her cancer, Anne tried to focus on eating nutrient-rich foods. One such food was kale. She began to plant kale and was surprised to find that what she grew in her garden was far more nutrient-dense than that found in the local grocery stores. As she looked further into this, she found that the same essential, beneficial functions microbes perform in our digestive systems are at work inside of the soil which we plant our crops in. By cultivating microbes in the soil of her garden, she was able to grow crops that were far healthier and nutrient-dense than those found at her stores. This finding, although seemingly obvious, can be very important, not just to Anne and David, but also to us, as it does affect us in our lives. Just as we can help and hurt our immune and digestive systems, we can also help and hurt the soil that we use to grow our crops. Herbicides are commonly used on crops, and they affect the microbiome of plants in many ways, causing the microbiomes to not work as they should, or not at all. Here in Cedar City, we have a lot of farmland that is treated with a variety of chemicals which affect the microbiome of both the plants and the soil. The most common herbicide that is used throughout America is glyphosate. A study done in order to determine how glyphosate affects mycorrhizal colonization and plant soil feedback found that soil microorganisms such as arbuscular mycorrhizal fungi, oftentimes abbreviated as AMF, were negatively impacted by glyphosate application on both target and non-target plants. This shows that glyphosate can negatively affect non-target plants, which could negatively affect entire microbiomes. As those microbiomes are negatively affected, the crops growing in that soil will also be negatively affected. As can be seen, this will affect our lives in many ways, including the health of our digestive and immune systems, and in general, our overall health. So now we come to the close. As can be seen, we share this world with another world that is so much smaller than we can see, and yet it plays such a critical role in ours. It affects the food we eat, how our bodies fight off infections, and the likelihood of our continued life. We can either help that microbial world or hurt it. So the real question is, now that you know a little bit about the microbiomes found in our world, are you willing to help them, or are you going to fight against them? We of course did not get all this information by ourselves, nor did we make it up. And so this is a page with our sources on it. Thanks for watching, and I hope you have a great day.